Okay, welcome to part 2 of our density notes. So now we're going to do 4 examples together. And so here we go. So our first example is a we do. So we're going to do this one together. So walk through it with me. So it says, what is the density of an object with a mass of 125 grams and a volume of 28 milliliters? So the first thing when I start to do a problem like this is I like to identify the information that's given to me. So the 2 pieces of information that I'm given is the 125 grams and the 28 milliliters. Now, if you remember from the front, 125 grams is a unit for mass. And milliliters, well, that is the unit for volume. So my 2 pieces of information that I'm given are mass and volume. So I must be searching for density, which makes sense from the wording of the problem, right? What is the density? So I'm looking for density. So the equation I'm going to use is D equals M over V. And so now I just want to plug in my information. So mass 125 over volume 28. And when it's 125 over 28, that means I want to divide. So in my calculator, I'm going to plug in 125 divided by 28. By the way, if you don't have a calculator out, now would be a good time to get out a calculator. And when I plug that into my calculator, I get 4.46428.571. But right now, 2 decimal places is a good spot. But although I have the math correct, I still need a unit. So remember, a unit for density might be grams over milliliters. And how I know that is because I did mass, grams, divided by volume. And here we can see our unit and our volume was milliliters. So I want to use the milliliters here rather than the centimeters cubed. Later on in chemistry, I will teach you how to round using chemistry things called significant figures. But for right now, 2 decimal places make sense, so that's great. All right, let's try example number 2 here. Okay, so in example number 2, it says, what is the volume of an object with a density of 2.34 grams per milliliter and a mass of 343 grams? So notice I underlined as I was reading the problem the pieces of information given to me. And here, grams per milliliter, well, that's a unit for density. And a mass of 343 grams. Grams is a unit of mass. So then that must mean I'm looking for volume, which makes sense from the wording of the problem, right? What is the volume? And if you remember from the front, our equation for volume is volume equals mass over density. So in order to do this problem, I'm going to do my math, which is 343 divided by density, which is 2.34. And I'm going to get out my calculator, and I'm going to do 343 divided by 2.34. And I get a volume of 146.58. Once again, doesn't really matter where you round to right now. If you round it to 147, that would be fine. 146.6, also okay. But what I still do need is definitely a unit. And so volume, we could either have, remember, centimeters cubed or milliliters. And because my unit and my density was milliliters, here my unit is going to be milliliters. Now, for those of you who care, how did I get that? Well, if I look back, I was doing mass, which is grams, divided by density, which is grams per milliliter. And remember from our math quiz that when we are dividing fractions, we would really be multiplying times the reciprocal. So here we would have like grams, and we could put that over 1, right, to make it a fraction. And so what you can see happens is my grams cancel my grams, and I end up with a unit of milliliters over 1, which is really just milliliters. And so that's how my units end up working out in this problem. All right. Now, if we were in class, I would give you a moment here to try example 3 by yourself. That's why it's called a you do. So right now you can just pause the video and come back when you're finished. Okay, so here we have a cube with sides that are 4 centimeters in length, and it has a density of 4.2 grams per centimeter cubed. Okay, so we have here our density, right, because our units are grams per centimeter cubed. But hopefully you caught this, that here, this is not one of our units for volume. So what it's saying here is we have a cube with 4 centimeters for each side. So what I need to do first is I need to find the volume. And remember that volume of a cube would be length times width times height. And here, those are all 4, so 4 times 4 times 4, which would just be 4 cubed, which for those of you who remember, 4 times 4 is 16, and 16 times 4 is 64. So my unit, or my volume here is 64. And my unit, as we talked about earlier, centimeters times centimeters times centimeters, would give me the unit of centimeter cubed for my unit. So now I can actually start my density problem because now I have volume in the correct units. So mass, if you remember from the front, mass equals density times volume, and my density is 4.2 times volume, which I just found was 64. And so using my calculator, 64 times 4.2 gives me a mass of 268.8. Once again, doesn't really matter where you round to. That was the answer my calculator gave me, so that's good enough for now. But I do still need a unit, and the unit for mass is grams. And for those of you who are figuring out where the units came from, here my unit for density is grams per centimeter cubed. And here my volume is centimeter cubed, which I can make a fraction by putting over 1. And so what ends up happening is my centimeter cubes cancel, and I end up with the unit of grams over 1, otherwise known as just grams. And that's where my units came from. Okay, so let's finish these notes with a challenge problem. All right, so let's scroll down a little bit. That was up. Let's scroll down. Okay, so it says gasoline has a density of 0.73 grams per milliliter. Okay, so density. How many liters of gasoline would be required to increase the mass of an automobile from 1,271 kilograms to 1,305 kilograms? Okay, so I have density. I'm looking for how many liters. Liters is a unit for volume. So I'm trying to find a volume. And here it says to increase the mass from this number to this number. So what I really want to find out is not the mass when it's 1,305. I want to know to increase the mass from 1,305. So I want to first subtract to find out how much mass am I increasing. And if I do 1305 minus 1271, I end up with 34 kilograms is how much I'm trying to increase my mass. Now here's why it's a challenge problem. My mass here is in kilograms and my density is in grams. So we need to convert to grams, which if you remember from a previous science class maybe, or the metric system, kilograms, there are 1,000 grams in 1 kilogram. So to convert this to grams, I would need to multiply times 1,000. So what I'm really trying to do is increase the mass of the car by 34,000 grams. That's why this is a challenge problem. All right. And so now this is my mass. All right. So I'm looking for volume. And remember that volume equals mass divided by density. And so I'm going to do 34,000 divided by 0.73. And I get a volume of 46,575 what? Well, if I look at my density, my units here were milliliters, so that would be milliliters, right? Because once again, I'm doing mass, grams, I put that over 1, divided by grams per milliliter. And so I'm really doing grams over 1 times milliliters over grams. And my unit left over is milliliters. But the problem with this problem right now is it asks how many liters is that? And my units are currently in milliliters. Once again, that's why this is a challenge problem. Still one more step. So for those of you who don't remember, there are 1,000 milliliters in 1 liter. And so in order to get my final answer, I would want to take my 46,575 milliliters, and this time I want to divide by 1,000 in order to get my answer in liters. And so my answer in liters would be 46.575 liters. Oops. And that would then be my final answer to this challenge problem. Now, would you see a problem like this on a quiz or a test? Probably not, but if you can do the challenge problems, it makes the other problems seem a lot easier. If you're wondering how we knew about the grams and kilograms and liters and milliliters, we'll cover the metric system later on in this unit, but kilo is probably one that you recognize as well as milli. So thank you for listening to the examples. You can now go show your notes to the sub and get the worksheet to work on today. And I hope to see you tomorrow. Thank you.